In this video, we are going to look at how to factorize polynomials. In particular, we're going to look at how to factorize polynomials of degree 4. So the highest power of x is 4. In a previous video, we have shown how to factorize polynomials of degree 3, which are called cubics. Polynomials of degree 4 are called quartics. So this is degree 4 polynomials are called quartics. However, cubics is definitely more popular than this quartics. Okay, so there are some tools that we're going to need to factorize these. The first one of them is the Rational Root Theorem. So if you are watching this and you're not up to speed with the Rational Root Theorem, we're just going to post a link of our video which explains the Rational Root Theorem. Something else that we're going to use is the remainder theorem. Again, if you're not up to speed with the remainder theorem, I'm going to post a link to a video that can refresh your memory on that one. And then lastly, we're going to use the method of synthetic division. Similarly, you're going to post a link for that one. I've already mentioned that we've done a similar video for cubics. I will also post that one. It might be helpful to start by looking at that video before you have a go or continue with this video here. All right, so let's get started. So for the first polynomial, we've got x to the power 4 minus 4x cubed plus 3x squared plus 4x minus 4. So just the summary of what the Rational Root Theorem tells us. So the Rational Root Theorem says the possible rational roots of a polynomial are going to be given by so if you take all the factors of the constant and take all the factors of the coefficient of the leading order term or the leading term, factors of leading term coefficient, and then if you do all possible divisions of these numbers over these numbers, then that gives you all the possible rational roots of your polynomial. In this case, for instance, the constant is -4 and the coefficient of the leading order term is 1. So what that means is that the possible roots we can obtain by listing all the factors of 4 in the numerator. Okay, then we list all the factors of 1 in the denominator. Since the denominator is 1, then this just works out to be the set of numbers in the numerator. So these are the only six possible rational roots of the polynomial we've got. Then what we do is we try each one of them one by one using the remainder theorem. So for instance, if you try p of 1, p of 1 is just going to be the sum of the coefficients here. So then 1 minus 4 plus 3 plus 4 minus 4. So 1 minus 4 plus 3 plus 4 minus 4. Look at the plus numbers here. It's going to be 1 plus 3, which is 4 plus 4, which is 8. The minus numbers, minus 4 is minus 8. So this is giving us 0. Then from this, the remainder theorem tells us, it's actually the factor theorem, that so x equal to 1 is going to be a root of the polynomial. And if we take this one to the other side, then we get x minus 1. So x minus 1 is going to be a factor. So both of these are of p of x. If that is the case, it means this polynomial here we can divide by x minus 1, and we expect that the remainder should be 0. So we do that using synthetic division. Then in synthetic division here we just put the coefficients of the polynomial we're dividing, then dropping 1 here and multiplying by this gives us 1, and then adding gives us -3, multiply by 1, and so the process is going to go on like that. And then of course the final number is 0 as we expected. So what this thing is telling us is that our polynomial we can write as x minus 1 times, this is going to be the coefficient of x cubed minus 3x squared plus 4. Okay, so then the next task is going to be to factorize this cubic. So what we're going to do, let's write this as x minus 1 times q of x, where q is standing for the quotient. So we are taking this to be equal to that. So then we're now going to focus our attention on the roots of this one. Now, since the constant term is the same value as we had for p of x, and the coefficient of the leading term is also 1, it means that the set of roots is still the same for q of x. So what we're going to do is we're going to start with 1, because if 1 is a factor of p, it could be a factor of q of x as well. Okay, so if we start with q of 1, it's going to be 1 minus 3 plus 4. This is going to be 5 minus 3, so this is not equal to 0. Then we go to -1. We plug in -1 here. It's going to give us -1 minus 3 plus 4. This is now working out to 0. So this is telling us that x is -1 is a root of q of x. Then again, taking the -1 to the left hand side, this tells us that x plus 1 is a factor of q of x. So that means we can divide this q of x by x plus 1. So again, we use the synthetic division approach. So the coefficients are going to be these ones here. 1 minus 3, 0, 4. 1 minus 3, 0, 4. So remember that since the power of 1 is missing here, we have got to make sure that that is represented by 0. So if you drop 1 and multiply by -1, add, multiply by -1, add. So this is telling us that the quotient we can write as x plus 1 times, and then from here going to be x squared minus 4x plus 4. This is now a quadratic which we can factorize straight away. So this is going to be x plus 1 into x minus 2 all squared. So this, remember, q of x is part of our polynomial. So what I want to do now is we're going to take that and plug it back into the polynomial. So p of x we can write as x minus 1 into x plus 1, then x minus 2 all squared. And then from this we can now write the roots. So the roots are going to be, so remember, the roots we get by taking each of the factors, equating it to 0. So from this one we get 1, from this one we get -1, and then from this one we get x equals to 2. So those are going to be our roots of that polynomial. Okay, so at this point we are going to continue to the next example. Yeah, in fact, we're going to bring this video to an end. Thank you for visiting our channel and watching our videos. We hope they are useful to you. Please do not forget to subscribe and to like the video. And if you've got any questions, you can post them in the comment section. So for part B and part C, please join us in part 2, in the part 2 video of this series. Thank you.